Hi everyone, and thank you for joining. In this video, we'll go over an example where we are applying multiple transformations to the graph of a function or to equation of a function. So we're going to start off with y equals negative 3 root of x minus 1 plus 5. We want to describe the step-by-step transformations that we would use to transform the function. Now remember that whenever we transform functions, it is very, 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 very important to check and see if k is unfactored. Remember that the standard form of equation of the transform function is a and then f k x minus d and then plus c. So as you can see in here, the coefficient k will always be in factored form. So it has to be in factored form before we state the transformations on any given function as well. So we're going to start off with the first one. We'll try to identify the coefficients first. So I see that the coefficient a right here is negative 3. So we'll write the value of the coefficient first. I'm going to check and see if I need to factor out k. Now, because k here is 1, there is nothing that we need to factor. So I'm going to write k equals 1 in here for now. And you see that in this square root x function, I am subtracting a positive 1. So that will make the value of d equal to positive 1. And lastly, we have number 5 added to the equation. So that will be the value of c equals 5. Now, since a is equal to negative 3, we'll say that the function has undergone a vertical expansion by a factor of 3. Or you can say that it is 3 times taller. And because of the negative sign in here, I'm going to change this color, the graph has also undergone a reflection of the y values, which happens over the x-axis. Now, since k equals 1, there are no horizontal expansions or horizontal compression, or no changes. Normally we don't have to write this, but just because I'm explaining this, I just brought it to your attention. So if d equals positive 1, it means that the function has undergone a horizontal translation in the positive direction because d is positive, 1 to the right then. And lastly, we have c equals 5, which means that the graph has undergone a vertical translation in the positive direction because c is positive, and that will be 5 up. So next we're going to look at this equation. We have y equals 2 square root of negative x plus 2 minus 3. So as you can see here, the coefficient in front of x is not 1, it's a negative 1. So that means we need to factor this out, and it's not in factored form. So before we state the transformations, we need to rewrite this equation properly, which means with factored k. So negative 1, and then we have x, the plus 2 will become a minus 2, and we're going to close brackets. I usually have the tendency to put this little line at the end of the square root to indicate that that's where the square root ends. It has to be very, very little and short, because I notice very often people mean to write, let's say, x minus 2, and then they just write x and then minus 2, assuming that this one continues. So we have to write things in proper form, just a reminder, everyone. So, and then we have minus 3 at the end. So I am going to highlight my coefficients in here because they're so important. They are changing my function. And we're going to say that a here is equal to 2. Coefficient k is negative 1. Coefficient d is positive 2. And coefficient c is negative 3. So with an a of positive 2, we're going to say that the function is undergoing a vertical expansion. So we can either say 2 times taller or by a factor of 2. Either or. Okay, so you don't have to write both. And k of negative 1, it doesn't cause any stretches in the horizontal direction, but it does cause a change in the x values because directly affecting x. So whatever x is changing to opposite because of this negative. And remember how x gets positive from going from one side of the y-axis to the other. So that's why we call this a reflection over the y-axis. Next, we have d equals positive 2. That causes a horizontal translation. Since it is positive, the translation will be in the positive direction to the right then. And c equals negative 3. That is my vertical coefficient, so vertical translation. And it is negative, which means that it's going vertically in the negatives, so 3 down. And this is how you would describe the transformations. And the same order in which you describe the transformations is the order that you use to draw the graphs of functions. So you would apply the stretch first, the expansion in this case, there are no compressions, and then reflections, and then the translations. So thank you for learning with me again, and bye for now. We'll follow up for the next part of the lesson, which is the multiple transformations on a graph.